Finite math. In this video, we're going to talk about cryptography. Just a brief introduction to cryptography and how we can encode and decode secret messages using matrices. As you go through the video, on the top left, you're going to notice some icons. This talks about the process. We'll do some examples. You get to practice. There will be a self-quiz at the end, and then what you need to do to get good at it. Remember, it's not magic, it's math. So what is cryptography? Now this comes from Wikipedia. Cryptography is about constructing and analyzing protocols that prevent third parties or the public from reading private messages. Various aspects of information security, such as data confidentiality, data integrity, authentication, and non-repudiation, are central to modern cryptography. Modern cryptography exists at the intersection of the disciplines of math, computer science, electrical engineering, communication science, and physics. Here's a picture of the Enigma machine. Variants of the Enigma machine used by Germany's military and civil authorities from the late 1920s through World War II implemented a complex electromagnetical polyalphabetic cipher. Breaking and reading of the Enigma cipher at Poland's Cipher Bureau for 7 years before the war and subsequent decryption at Bletchley Park was important to the Allied victory. If you'd like to know more about the Enigma machine or about cryptography, all you need to do is go to YouTube and type in cryptography. Cryptography is constructing and analyzing protocols that prevent third parties or the public from reading private messages. So in the 21st century, how does cryptography work? Well, let's look at this little picture. So you're going to send a message to your friend. It goes as plain text. Then it gets encrypted by a public key. The encrypted text then goes to your friend's computer, where it gets decrypted using a private key, transforms into plain text, and you receive it. Now, how does that work with matrices? We're going to have matrix A times matrix B. Well, matrix B is the plain text. Matrix A is what we're going to use to encrypt the text. And then our matrix D is the encrypted text. On the other end, we're going to take A inverse times D, and that will be our plain text to read. A inverse is how we're going to decrypt the message. D is the encrypted text we just received, and then B is the plain text. That's what we originally sent. Let me show you how it works. First, we're going to learn how to encode or encrypt a message. To begin, assign the numbers 1 through 26 to the letters in the alphabet as shown below. Also, assign the number 0 to a blank to provide the space between words. Now, I recommend you write this down. Then we're going to create a 2 by 2 encoding matrix that has an inverse. Now, this 2 by 2 matrix is our A. We're going to regroup the numbers into a matrix into groups of 2, which is our matrix B. We're going to multiply the encoding matrix by the regroup number matrix, so that's A times B, and the result will be our encoded matrix D. Matrix inverses can provide a simple and effective procedure for encoding and decoding messages. To begin, assign the numbers 1 through 26 to the letters in the alphabet, as shown below. Also, assign number 0 to a blank to provide space between words. We're going to make the message secret code. Where are these numbers coming from? Well, if I look at S, S is 19. E is 5. C is 3. R is 18, and so on. And so these are the numbers for our secret code. What we have to do next is any matrix A whose elements are positive integers and whose inverse exists can be used as an encoding matrix. For example, to use the 2 by 2 matrix, this one, 4, 3, 1, 1, to encode the message first, divide the numbers in the sequence, this is our sequence, into groups of 2 and use these groups as the columns of a matrix B. I want to mention that in your homework, for a lot of you, you'll already have an encoding matrix. So you don't have to worry about figuring that out, making sure that the matrix has an inverse. It'll be given to you. The encoding matrix, well, that's randomly picked numbers for matrix A that also has an inverse. That's important. But once again, it'll be given to you. Here is our matrix B. How did I make this? Well, the first number is 19, then right below it, it's 5. Then we have 3, then below that 18, 5, 20, and so on. It's really important that you put them on top of each other, otherwise it's not going to work. This is our plain text. We added an extra blank at the end of the message to make the columns come out even. Then we multiply this matrix on the left by A. Remember, we're taking A, the encrypted matrix, which is 4311, times our plain text, which we just did, was 195318. And that gives us D. That gives us our encrypted matrix. That's the encrypted message that gets sent to our friend. The encoded or encrypted message is 91, 24, 66, 21, 80, and so on. Okay, it's your turn to try. Now I know it's a little confusing, but try this by yourself. You're going to encode. Math is cool. You're going to use this encoding matrix. Pause the video, do it, and then we'll work it together. Let's see how you did. First, we need to create matrix B using the sequence of numbers found above. Divide the sequence into groups of 2 and use these groups as the columns of matrix B. Remember, the first letter, M, is 13, and that goes first, and then right underneath it is the second letter, A. And then we have 20 on top, 8 on the bottom, that's T, H, and so on. List the elements of each column of A, B in order to display the coded message. Now A is our encoding matrix, so what we're going to do is we're going to encode this secret message. Math is cool. To do that, we're going to go to Symbol Lab. First, we are going to put in our 2x2 encoding matrix, and now we're going to multiply our message to make it a secret. I'm going to go here to my matrices, and this one is 1, 2, 3, 4, 5, 6. So it's a 2 by 6. Okay, let's start putting our numbers in, and now we're going to go and multiply it. Now this is the message that's encrypted. That'll be sent to our friend on the other end. Now I'm going to show you really quickly your friend, how they're going to decrypt it. First thing we need to do is put in our A inverse. And our A is a 2x2. Now I'm just going to put in the actual A. But then I'm going to over arrow, and I'm going to make the exponent a -1. So that tells us it's A inverse. Now I'm going to multiply by, now I'm going to make our 2 by 6 message that we are sending, the secret coded one. Now when I press go, look at that. It's the original message, 13, 20, 0, 19, 3, 15. So when your friend gets it and decodes it, now when your friend gets it and decodes it, they're going to figure out that math is cool. Now, how do we decode? Well, I showed you a little bit just a second ago, but first we're going to find the inverse of the encoding matrix, multiply the inverse encoding matrix by the encoded matrix D, and then the result is the original encoded matrix B, just what we did a second ago. Okay, now here is a message we just received from our friend. The message is 32, 47, 22, 26, and so on. What we need to do is we need to decode it. So here is our D. The first number goes on top, and then bottom, top, bottom, and so on. Then our A inverse is 3, -2, -1, 1. We're going to take A inverse times D, and that will give us B, which is 2, 14, 0, 1, 5, 0. What does that spell? Well, 2 is B, 15 is O, 14 is N, 4 is D, 0 is a blank spot, 10 is J, 1 is A, 13 is M, 5 is E, 19 is S, blank spot, 2 is B, 15 is O, 14 is N, 4 is D, and a blank spot, which gives us Bond, James Bond. Now let me show you really quick how we put that on Symbol Lab. So what I did was, here is our original matrix A. Now to get the inverse, all I have to do is actually put the matrix in and put to the -1, and that'll give us the inverse matrix. And here is our secret message. When I put it in, we end up with 2, 15, 14, 4, 0, and so on, which tells us Bond, James Bond. Okay, you get to decode this one by yourself. Pause the video, do it, and then press play to see what the secret message is. All right, let's see if you got the secret message. So our D is 29 over 34, 39, 57, and so on. What we're going to do is we're going to take the inverse of A and multiply it by D. That's the coded message. And what we get out is B. What is the message? We have 19. We have 19, which is S, 5, which is E, which gives us Secret Agent Man. Let me show you how to do it on Symbol Lab really quick. So all I did was I took A, 1, 2, 1, 3, to the -1, because that gives us A inverse, multiplied by our secret message. And what do we get? We get our message, 9, 3, 5, 0, 7, 14, 0, 1, and so on. Cool. What do you need to do? You need to practice, 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 practice. And even if your teacher says the homework doesn't count towards your grade, you still need to do it. Did you like the video? Why don't you like it? Did you really like it? How about you subscribe? Did it help you? Why don't you share it with a friend? Remember, it's not magic, it's math.